Okay, everybody. First off, just a refresher of Intro to Psych. Some of the things you may have remembered, you should have learned in Intro to Psych. Um, so, specifically related to developmental psych, what are some of the things that we will talk about in developmental psych, and how does research help us understand what's going on with development? So these are some links to stories that I will provide you with this PowerPoint as well, in an attachment. So you can click on these research stories and read a little bit about them. Okay, so we're going to talk today about the basic principles of research and how they can help us understand developmental psychology. So we know that psychology can help us understand other people, help us understand ourselves and relationships. And really, one of the main goals of psychology is to help improve our lives and the lives of others around us. Developmental psychology is, as you probably read in your textbook, the study of the lifespan from preconception to death, dying, and bereavement. And we will talk about all of those specific stages as we go. One of the things that's really neat about developmental psychology, in my opinion, is that we've all experienced many of these stages of development, either ourselves, or we're raising children or caring for relatives. So we all have a little bit of real world experience with a lot of what we talk about. So psychology, if you remember from intro, is the study of behavior and mental activity primarily. So here's a picture of my daughter when she was just a little kid. It's pretty easy to describe her behavior here. What is she doing? What is her expression? That kind of thing. The basic descriptions of her behavior are pretty easy to observe and record. The mental process part is a little bit more difficult. If any of you have been around preschool age children, you may know that they sometimes do things that just make you scratch your head. What on earth? This was her outfit for swim class. So the bathing suit is appropriate. Not sure about the boots and the backpack and the straw decorative umbrella that she found somewhere. So observing behavior is pretty easy. We can see what she's doing, see what she's wearing, even the sort of expression on her face and things like that. But understanding what the mental process is a little bit more difficult. And particularly in the early stages of development, when children are not yet speaking, it can be more difficult to understand their mental process. So we will talk about some of the basic issues of nature and nurture. And it's really, we used to say nature versus nurture. It's really nature and nurture working together to sort of build this person and this personality. And so in the next slideshow or the next video, we'll talk about genetics a little bit. And so these are some topics that we'll talk about: the influence of our biology and the influence of the environment around us. When studying psychology or any of the social sciences, it's always really important to be a critical thinker, to evaluate what the information is coming at you from whatever the source is, and try to be skeptical when you first get new information. Ask yourself, what am I being asked to believe or accept? What's the evidence provided, and what are some reasonable conclusions? So some of the current events in psychology and in popular culture, and you may see in the news, are some questions like, is there any connection between vaccines and autism? And this is something that's been studied extensively in the last 20 years in particular. And I really encourage you to do some research yourself on that. What is the effect of gun laws on preventing gun violence? Are they effective? Mozart, does listening to Mozart music make babies smarter? And what is the relationship between genetics and mental health? So these are all some sort of current and recent hot topics in psychology. So when we're looking at any of these ideas or research studies, it's important that we're using the scientific method. We are, constantly exploring from the moment we're born, exploring the world around us, even prenatally, and trying to understand the world around us, observing, asking questions. Again, particularly as kids start to become verbal, this is one of the things that you see a lot with very young children, is that asking questions. And they're really trying to figure out the world around them and use the adults around them to help them figure out the world around them. We use the scientific method on a daily basis without really even realizing it. If you think of if something goes wrong with an appliance of yours or a car, we try to figure out what the problem is. We come up with a hypothesis, which is a tentative explanation. My car won't start, for example. We can hypothesize, make a guess that maybe it's out of gas. Maybe there's a fuse, and I am no car expert, so those are pretty much my only ideas. Oh, the battery, maybe, right? So we can start to test these hypotheses and collect data. And then we analyze the data. So does filling the car with gas help? Does charging the battery help? That kind of thing. And then we draw conclusions. Even if we take a car to a mechanic, nowadays, many of them will collect the data by simply hooking the car up to a computer of some sort, which will then analyze the data for us and sort of spit out a conclusion, how to fix that problem or what the problem might be. Another really popular question is, does sugar make kids hyper? I've seen this little sign here at the library, which I just thought was funny. So again, we come up with a theory, an overall sort of idea, the hypothesis, possible explanations for this. We collect the data and we analyze the data and we draw a conclusion. So again, in the link, I'm not sure if you'll be able to play this from my video, or if you'll need to go to the PowerPoint to watch this video that explains the research on sugar and hyperactivity in children. One of the terms I'd really like you to pay attention to is this confirmation bias. It's the idea that we pay more attention to the information that confirms our hypothesis than to the information that might not confirm what we believe. So pay attention in particular to this term. This is a really important thing that researchers need to guard against, is making sure that we're not paying more attention to the information that we kind of like and ignoring the stuff that might negate our hypothesis. Ethics is always important, particularly in a subject like developmental psychology, where we're studying almost entirely human subjects. We always need to keep in mind that our subjects cannot be harmed in any way, and as much as possible, without revealing the contents of the study, subjects need to give consent, or the guardians of the subjects need to give consent, and their information must remain confidential. So if you remember again from psychology, from Intro to Psych, there are 3 major types of research: descriptive, correlational, and experimental. And these are all ranked in the degree of difficulty. So descriptive is relatively easy to do, but also in terms of how powerful they are. So descriptive is relatively easy to do, but doesn't allow us to draw any conclusions or show any cause and effect, whereas experimental is more difficult to do, but can allow us to show that cause and effect between two variables. So descriptive research is really easy. Again, it observes and describes behavior. We can do this just by watching our subjects and recording their activity. It can be done sort of in the wild, in a naturalistic observation, or in a laboratory setting, a preset setting. So in early developmental psychology, you'll see a lot of research observations made on children in their natural environment. And again, this is relatively easy to do. A structured observation would occur in a laboratory or in something like a observational classroom, which might be a classroom with a double pane window that looks like a mirror on one side for the subjects, and the observers can see and sort of observe without interfering with what's going on in the classroom or laboratory. Other types of descriptive research: surveys and interviews. These can be structured interviews or unstructured, things like questionnaires, phone surveys. We've all gotten those phone calls. But they are very useful at gathering large amounts of information, as well as standardized tests, which many of us have taken. It's a quick and easy way to gather a lot of information. But again, it doesn't allow us to make any connections or draw any conclusions. Many times descriptive research is kind of the first stage of an overall research study, just to gather information. A case study is another type of descriptive research. This is done when there's a rare symptom or disorder or situation where we study a small group or even a single individual to see, what happened, what's going on. One of the earliest case studies in neuroscience is this individual, Phineas Gage. And again, you can either click on this link here in the video. If that doesn't work, go to the PowerPoint that's provided with this to click on this link to read a little bit about Phineas. Correlational research describes how strongly two or more events are related. It does not show cause and effect, but it's a little bit more powerful than the descriptive research. So this is where we start to see that things go together. Positive correlation is when both factors increase or decrease together. So they go in the same direction. One goes up, the other goes up. One goes down, the other goes down. Negative correlation, they're sort of the inverse. So as one increases, the other goes down, or vice versa. So an example of negative correlation might be, as the temperature rises, the amount of clothing we need to wear goes down. And the opposite of that would be, as the temperature decreases, the amount of clothing we need to wear goes up. Does this mean that the weather causes us to dress in a certain way? Not necessarily. Correlations do not show cause and effect. They only show that two variables are related. There could be other explanations for the clothing that we're wearing outside of the weather. The only way to show cause and effect is with an experiment, which we'll get to in the next few slides. So some other examples of positive correlations, and again, these are factors that go together, not necessarily caused, one causing the other. But typically the more hours you study, the higher your grades. The more you work, the more you make. The less you eat, the less you weigh, the less you practice, the less you learn. Again, these are things that go together, but in correlational research, we cannot necessarily show cause and effect. You have to do an experiment for that. Negative correlational examples: the more you work, the less you play. The more you spend, the less you save. The less a baby is held, the more they cry. Now, when we talk about early childhood development, one of the things we talk about is colic in babies. And if you've ever cared for a baby with colic, you may realize that pretty much nothing you do for a baby with colic alleviates the crying. And this can be a very significant factor in parental stress that we'll talk about in the early chapters of development. So again, these are things that are related, but we are not able to show cause and effect. Okay, so again, I say this again because this is very important. Correlation, just because two things go together, doesn't mean one causes the other. The only way to show cause and effect is with an experiment. So, with an experiment, we manipulate factors to show cause and effect. And you, again, may remember these factors are called the independent and dependent variables. The independent variable is what the experimenter is going to change or manipulate. And then we look at what the effect of that change is on this other dependent variable that we're looking at. So the independent variables are the ones that we manipulate or change. The dependent variables are what changes in response to that independent variable. So many times an easy way to figure out what's the independent variable and what's the dependent variable is to plug it into that cause and effect sentence. So the independent variable causes the dependent variable. Okay, so a very commonly used term is that smoking causes cancer. The problem with this is that ethically, researchers really have not been able to, until very recently, done a rigorous experiment with cigarette smoking and looking at it causing cancer, because you would have to assign randomly individuals to smoke for a long period of time. And we can't randomly assign a variable that we know is very, very likely to cause harm. Ethically, we can't do that. So all of our research with smoking has been done correlationally. We look at people who have smoked for a very long time, and what is that relationship with their cancer cases. They do have a higher rate of cancer in individuals who smoke for a longer amount of time, but we didn't impose that variable on a random group of individuals. So they all had made the choice to smoke, and then we look at what the effect was of that. That's a correlation. We didn't randomly assign individuals to smoke and then see what happened. Now, very recently, scientists have sort of declared that the body of correlational research on smoking and cancer is so significant that we really understand now that smoking does cause cancer. Also, research has been done at the cellular level, introducing cells to the toxins in cigarettes, and that does show changes that are associated with cancer. So that's an example of an experiment, because we're using cells, but not actual human individuals, and randomly assigning those cells to cigarette smoke or the toxins in cigarettes. Also, in a good experiment, we should have a control group. A control group gets something very similar to that independent variable, but not exactly what is being tested. So with the experimental and control group, we're looking for that placebo effect, that effect of somebody in a white lab coat giving you a medication and saying, this is going to make you feel better. We have seen in extensive research that that can have a significant effect on individuals believing that they feel better. That's the placebo effect. But what we're looking for, especially if we're doing drug research, if we're going to give this medication to a large group of individuals, we want to know that it's actually that medication and not just the placebo effect. So experimental research has the experimental group that is manipulated, and the control group, which is treated the same way, except they don't receive the particular drug that we're testing or medication or treatment that the experimental group does. And again, we're trying to rule out that placebo effect that can take place. So some examples of placebo. So testing, does aspirin help a headache? So you would give the experimental group the aspirin and the placebo group a sugar pill and tell both groups, this is going to help your headache. And then in an hour, we reevaluate both groups and see whose headache is better. Now, aspirin has been well tested at being effective at alleviating headaches, so we would expect in that example that the aspirin would work better than the sugar pill. Some other things that have been used: real acupuncture and fake acupuncture needles, and this has actually been done. And acupuncture has been shown to be effective in certain things, particularly alleviating nausea in pregnancy, which is a really important tool because there are so few drugs that can be given to pregnant women. To use a non-drug alternative is a really great option. Other examples of placebo: sitting with a trained therapist and chatting, or a pseudo therapist and sort of just chatting, and sitting with a therapist using actual therapeutic techniques. Another example would be the effect of real beer with alcohol in it and near beer that tastes like beer but doesn't have any alcohol in it. And if you'd like to do a little research on some of the studies that have been done with non-alcoholic beer and real beer and what happens to individuals when they consume a significant amount of beer that they believe has alcohol in it, some of those studies are pretty interesting. So random assignment is important in this experimental research. We try to randomly choose our subjects from the population and then randomly assign them to either the treatment condition, the experimental group, or the placebo group. And again, this can be difficult to do. It's not always possible, but that's the ideal. Experimental research should also, if possible, be a double-blind experiment. So if I'm testing the effect of aspirin versus a sugar pill and I'm administering that medication, I should not know until the research is concluded who got the aspirin and who got the sugar pill. So that reduces my bias as well. Again, it's always important to protect our subjects from harm. They need to be given informed consent. You may be given a medication which may contain an aspirin-like substance, or these could be the side effects, bleeding, that kind of thing that can happen with a drug like aspirin. So as much as possible, you need to inform your subjects that they might ingest a medication that could be harmful to them. You would want to medically clear your subjects to make sure that you're not causing harm. You need to maintain the privacy of your subjects, so you can release the results. Group A had this effect, Group B had this effect, but you would never reveal the individual information about your subjects. And after the conclusion of the study, the subject should have access to those results. And if the treatment was shown to be effective, that effective treatment should be offered to the members of the control group who didn't get any of the actual medication. So this is seen many times in treatment for diseases like cancer and things like that. If Group A received the chemotherapy that's being tested, and Group B got the placebo, and the chemotherapy that was being tested is shown to be effective, the placebo group should be offered that beneficial treatment at the end of the study. All right, so that's it for our little research sort of overview. Please check out some of the other lecture videos that I'll be posting.